So earlier this week, there was an announcement made about prime numbers.
Yep.
And can you tell me some prime numbers? Maybe from the beginning.
2, 3, 5, 7, 11, 13, 17, 23.
There's also 19.
19,
19.
23.
Okay. And you tell me, what's the definition of a prime number?
Well, it's a number that's divisible by only itself and 1.
Okay. Anything special about that number?
Well, it's not necessarily odd. There's one even prime.
Okay. Is pi a prime number?
Well, no, it has to be. They have to be integers.
Okay, so they have to be integers. But the neat thing is prime numbers are pretty random.
Yeah.
And mathematicians, up until this week, really believed that prime numbers were really good approximations for random numbers. And that there was just not very much structure of any consequence in prime numbers. And there's some super cool theorems kind of relating to prime numbers and randomness.
Yep.
One especially really neat one is called the Erdos-Katz theorem. But this week, someone asked a very interesting question. Well, they probably asked the question a couple weeks ago. They just published a paper about it. They said, we're look at the odd prime numbers.
Yeah.
Okay, and we're going to look at the last digit. Okay, so what are potential last digits for odd prime numbers?
Well-
So 1, 3, 5, 7, and 9. Yeah.
Yeah, there are all of those.
All right. Anything more we can say about these particular last digits?
Well, the 5 is only going to happen once.
Oh, why is that?
Because the only prime number that ends in a 5 is 5.
Why? Why isn't it like 35 prime?
Because
Because
it's divisible by 5.
it's the only prime number that's divisible by 5.
Huh. So 5 is kind of similar to 2 in that respect.
Yeah.
2 is the only prime that's even. 5 is the only prime that ends in a 5. And so what these mathematicians did is they said, for our purposes, 5 and 2 are not that interesting.
Yeah.
We're going to look at primes that end in 1, 3, 7, and 9.
Yeah.
And I think probably what they did first is they looked at 1, 3, 5, 7, and 9, and they found that there were about the same number of them.
Yep.
You know, as you went up, as you got big. Just kind of like rolling our dice. But then they asked a pretty interesting question. How about if I have a prime that ends in 3? What's the next prime? What's the very next prime going to end in?
Well,
What would you think before we run this experiment?
Well, if we
On average, just kind of like our die.
well,
There's 4 choices.
if we start with 3,
If we start with a prime that ends in a 3, let's say like 23 or something,
3.
or 3.
3.
Well, but we're not bringing 5 to this party, so we'll start above 10, so 13 maybe or 23.
13.
well, I would think that a prime ending in 7
Uh-huh.
would be the next one.
Or 9.
Well, on average, I think 7 because like there's 37, 47, 50. Well, not 57.
Well, but 13 goes to 9. 23 goes to 29.
That's true.
There would be some, yeah, that would not go to 7.
Okay. How about a prime ending in 9? What do you think would be the next last digit that you would see?
See 9. Maybe we would go back to 1
Okay. Why?
because you are at the end of the list and you go back to the start of the list.
So it could be like a loop.
What do you think?
Well, I would think either 1 or 3.
Okay.
Because most of the time there will be primes in the next set of like 10 or 20. Yeah, in the next set of 10 that end in 1 or 3.
Okay.
Most of the time.
That's interesting. And so I think the mathematicians actually kind of thought along the same lines you guys did, that, you know, you might expect maybe if you start at 3, you might expect 7 to be sort of the next most common one, and then 9, and then back to 1, and
Yeah.
then maybe 3, and it would be, you would see some distribution.
Yep.
But as you got large, like as you got into the numbers that were like, 9, 10 digits long,
Yeah.
that you wouldn't have a huge effect from that pattern, because it wouldn't be the case there that you would expect the next set of 10 to have primes, because primes would kind of spread out a little bit.
Yeah.
No one knows for exact sure, but they spread out a little bit. They're still random.
Yep.
And so they thought over time you'd end up actually like a die, so it'd be sort of evenly distributed.
Hmm.
And then they found something surprising.
Yeah.
So let's go up to the computer. We'll write a little Mathematica program and see what we can find.
Okay.
Okay?